EcosimPro and PROOSIS are software tools for simulating and modeling systems. In the next example, we'll make a model and simulation of an open-loop system. This is a linear third-order system expressed by its transfer function. Its purpose is to simulate its response upon a step input. In this case, a unit step. Its amplitude is 1. First, we load the Book Examples toolkit into the workspace. Next, build the model by clicking on the menu option in File, New, Schematic. After typing in the name of the component, we drag symbols of whatever components we want onto the new schematic window. We include an instance of the transfer function component to implement a transfer function, and the analog source component to configure different input signals. By double-clicking on the instances, we can set up the parameters and data of the instances. Then, bring up the contextual menu on the Items tab of the library and click on the Edit Source Code option to display the component's code in EL language. For the analog source component, what we want to modify is the source data that sets the wave shape to source step. For the transfer function component, the data amp sets the wave amplitude, in this case at a value of 1. The t-start data is the moment in time of applying the input, in this case 0. All the other parameters are modified to establish the equation, and num for orders of the polynomials of the numerator, and den for orders of the polynomials of the denominator. The data p and q are vectors that contain the coefficients of the polynomials of the numerator and denominator in the transfer function. Now we connect the ports of the two instances by clicking on the connection button and moving the cursor over to one of the ports. When you see the anchor, click again to connect. You can do it the quick way by pressing Shift-click on the first port and then clicking on the other port. Finally, we create a default partition and an experiment. We compile the experiment and run the monitor. This creates a plot that displays the output of the system for the given input. In conclusion, this video has shown how to represent the behavior of an open loop system by creating the system with different components from the control library.